Welcome to our lesson on sublevels and orbitals. Today, we're going to explore the four types of orbitals that exist within electron energy levels: s, p, d, and f orbitals. Each of these orbitals has unique shapes and properties that determine how electrons are arranged around the nucleus of an atom. Understanding these orbital shapes is essential for comprehending atomic structure and chemical bonding. Before we dive into specific orbital types, let's establish an important concept. Each energy level, represented by the principal quantum number n, contains one or more sublevels. These sublevels are designated by the letters S, P, D, and F. Think of energy levels as the floors of a building, and sublevels as different rooms on each floor. The number and type of sublevels available depends on which energy level you're examining. Let's look at how sublevels are distributed across the first four energy levels. The first energy level, n equals 1, contains only the 1s sublevel. The second energy level, n equals 2, contains 2s and 2p sublevels. The third energy level, n equals 3, has 3s, 3p, and 3d sublevels. Finally, the fourth energy level, n equals 4, contains all four types: 4s, 4p, 4d, and 4f sublevels. Notice the pattern. As you move to higher energy levels, more types of sublevels become available. Now let's examine the s orbital, which is the simplest type. The s orbital has a spherical shape, meaning it looks like a ball centered around the nucleus. This spherical shape is the same in all directions, making it perfectly symmetrical. Each s sublevel contains only one orbital, and since each orbital can hold a maximum of 2 electrons, every s sublevel can hold up to 2 electrons total. The p orbital has a distinctly different shape from the s orbital. P orbitals are dumbbell-shaped, with 2 lobes extending in opposite directions. There are 3 p orbitals in each p sublevel, and they're oriented along the 3 perpendicular axes, px, py, and pz. Since each of the 3 orbitals can hold 2 electrons, a complete p sublevel can accommodate up to 6 electrons total. Moving to more complex shapes, we have the d orbital. D orbitals typically have a cloverleaf shape, with 4 lobes arranged in a plane. Each d sublevel contains 5 d orbitals, oriented in different spatial arrangements. Since each orbital holds 2 electrons, a complete d sublevel can hold a maximum of 10 electrons total. D orbitals first appear in the third energy level. The f orbital has the most complex shape of all. F orbitals are multi-lobed structures that are difficult to visualize due to their intricate three-dimensional arrangements. Each f sublevel contains 7 f orbitals, each with different spatial orientations. With 2 electrons per orbital, a complete f sublevel can accommodate up to 14 electrons total. F orbitals first appear in the fourth energy level and are important in understanding the chemistry of rare earth elements. Let's summarize what we've learned. The s sublevel has a spherical shape with 1 orbital holding 2 electrons maximum. The p sublevel has a dumbbell shape with 3 orbitals holding 6 electrons maximum. The d sublevel has a cloverleaf shape with 5 orbitals holding 10 electrons maximum. And the f sublevel has a complex shape with 7 orbitals holding 14 electrons maximum. Understanding these orbital types and their electron capacities is fundamental to predicting how atoms will bond and interact with each other in chemistry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.